we can also hear the students on Zoom, so that's good. Okay, there is so the still a preliminary teaching schedule. So we are now at in week 37. And for the students that are on the campus, they should now be able to sign in for the laboratory exercises.
How should they sign for the laboratory exercises?
If you log in and fill out your date, the number and data that you got in you should come in and for each individual exercises, and then you can. There is I think it's a timetable that you click on and put in your name in the timetable. So the reserve time throughout the whole week, spread a little bit around. Maybe someone will collide with your ordinary lecturing time, but you choose times in between. And I expect that it's probably not more than 20 students that are going to do the laboratory exercises that are present at campus. You never know. Yeah.
I tried setting it up, but it doesn't work.
It doesn't work.
It hasn't activated.
The same for
Go. Which exercises did you use? Exercise 1.
Yeah, the same. Like I tried also. It was not taking.
Take exercise 2.
Okay.
2 and 3. Test exercise 2 and 3. Maybe exercise 1 is not working yet.
So
Exercise 2 and 3.
even for exercises 2 and 3, we cannot like put in our names.
You cannot put in your name. So then I need to talk with the people and see if there is something wrong. No? I haven't. I'm not planning to sign in for the exercises myself, so I don't know if it works. So and maybe that's the reason. But I know that there are students that have signed in. But maybe there is something wrong. Why they said that there was not very many students that have signed in, and maybe that's the reason. That is something technically wrong.
Okay, so maybe
It works on you for you. It works.
It works for me, but it doesn't work for.
Does it work for you as well? Or you?
So I think maybe it could be because we are using MacBooks.
Mine was filled in automatic.
Automatic.
Huh?
You didn't actually type anything.
I typed in my number.
Yeah. So maybe it's there is always a problem with different type of computers or handheld units. So
Phone number works and email.
Yeah.
Oh,
the
phone
same.
number, just an email.
okay. So the Macs are okay. You have to buy a new computer. Okay, you can borrow another computer or take one of the student machines around at the campus and try to log in there. That's the solution, I think, easiest solution. So for the people who are on IBM compatible computers, it works. Windows 10 works. Apple is Apple, living their own lives. Probably have to pay money. Okay, so there is a possibility now, and I think next week there's opening for starting the laboratory exercises. So sign in as soon as possible and get it done. Next week we will introduce the problems or exercises that are following this course for calculations and things like that, because today we will complete PVT reports, and next week, in week 38, we will start looking into the theory around the calculations, and so we start with gas and using the equation of state, simple calculation, and then we move a little bit further, gas, condensate, and liquid.
Professor, may I ask a question?
Yes, please.
Yes, would the exercises in the laboratory be recorded for the international students to view it, at least on Canvas?
Yeah, so the problems will be the problems solving is also will be done partly, or we will have a Zoom meetings on for the exercises. The laboratory work will not be published, no videos or anything taken from that. It's a practical work that we are working in the laboratory. It's very difficult to do a proper visual presentation of it. So we are not doing it.
So it should be only numerically done, right?
Physically, you have to be physically.
I meant for the international students outside Norway. They would just do the exercises like manually, numerically. I mean.
Numerically, there's no given numbers. They are, but in the problems and in the lecturing, we are going through the same things that you're doing in the laboratory from a numerical point of view. But it's more the practical approach on how to do it, so you get familiar to that is given in the laboratory exercise. And if you are not present, it's everything is just numbers. But the numbers and the solution of that is presented. So all exercises is presented in the lecturing and will also partly be touched in the problem solving.
All right, thank you.
So it shouldn't be any problem for the students that are not present. You have been through it, and at the end, the exam will take into account that there are students that have not participated in the laboratory work.
Thank you.
Yeah. Good. So as I said, today we will continue looking into the PVT reports. That's the plan, and on Monday we will continue with the calculations and start with gases that are the simplest way to calculate, do fluid calculations, the properties of fluid. And as I said, and on Thursday next week, we will have 1 hour lecturing on fluids, and then we'll start the second hour we will use for the exercises, an introduction to the exercises. And the exercises, the problems, and Excel file with solutions of the problems is already now should be published now, have been published now on Canvas. I did it just before I arrived to the lecturing room, so hopefully everything's okay. Okay, so that's the plan further. So yep.
I just had a question regarding the recording of the lectures, because I missed last week's Zoom lecture or the streaming because I had a doctor's appointment and I didn't quite make it home in time. I got the last bit of the lecture, but not the first. And I was wondering if it's just me who can't find it on Canvas, or if you haven't shared it.
Haven't been recorded due to some computer problems and things like that. So in Zoom,
right,
you store it on the computer that we are using, and so I have been changing computers in between, so it's been a problem to get it. And I've got the error messages on my laptop that it's not space enough to store it. So
okay, yeah. Do you think
lectures have been stored?
Okay, so will it be sufficient just to read through the presentations, do you think, or will it be quite, or should I, yeah, do you think there'll be?
You have background information in the compendium and also recommended tips, and there is all lecture notes have been published. But
okay, cool.
Definitely, it is probably better to follow the lectures, but for the time
yeah, for sure.
Be present. Sorry for that, but
no, that's okay.
It's partly due to computer problems, and so
okay.
That's
yeah, okay,
and
no worries. I was just wondering.
It did not be recorded either.
Okay.
So because the laptop was had a laptop problem, so I have to use the computer in the auditorium. So.
Oh right, yeah, okay, no problem. Just figured I'd ask, so that's okay.
So good. they are allowed to ask for absolutely everything, and not everything could be answered, but we tried as best as we can. Okay,
Cool.
so problem solving, as I said, it will be, we will go through it in the second hour on Thursday, next Thursday. But there is 10 problems, and you are going to solve, we will come up with a list of which type of problems you should look into. Someone is linked to gas, someone is linked to gas condensate, someone is linked to oil with dissolved gas. And we give you an overview of that. And then the student assistant will, he will present the problems, but he will also help you each week with a Zoom meeting. So you can ask questions, and he will also probably come up with a sketch solution of most of these problems. If you want to solve it on paper instead of looking into the Excel sheet. But all the solutions are given in the Excel sheet, but you have to look at the numbers in the individual columns to understand it. Good. But as I said, there is a student assistant to support you in this. And then it was the exercises in the laboratories at the campus. So there are 3 different laboratories that you need to look up for doing it. Exercises 3 should also be in, I think, I'm not sure about the number. I have to check it up, but and give feedback on that. But it's probably given in the, when you have signed in, you should know where you find it. And as I said, 2 students for the laboratory exercises should group together and do all the exercises together. And the delivery of a written group report. What? When you are signing in, you are signing in.
In geology or in PVT?
In PVT.
No.
It's not. You have to sign in as groups, or you have to know who you are in group with and sign in at the same hours on the laboratory exercises. So you group yourself. Oh, I think there is automatic sign-in that didn't work on the Mac, and so that's the way it is in this digital world. Okay, was there anything more to say here? No. Then we will continue with the PVT report. We started with the gas condensate, and but we ran out of time to complete the gas condensate. So now I need to find my okay. Okay, can they get rid of the damn? Okay, so we started working with the PVT report on gas condensate, and we went a little bit. What we did, there was a introduction page. We looked in the introduction part of the, and then it was a sampling sheet. And then what we did is in a way, we measured the bubble point of the separator liquid. So the gas condensate arrived to the laboratory as a as a separator liquid and a separator gas. We did bubble point evaluation of the separator liquid, and it fits quite well with the separator pressure, confirming that most likely it's a correct sampling of the fluid. Then there was a single flash of the separator liquid to standard condition to do a chemical analysis of the stabilized oil and the evolved gas from the separator liquid. And we recombined it according to the GOR measured during the flash. On a more detailed composition of the fluid, up to C10 and up to, and this is the detailed composition of separator gas taken from the separator, the bottle from the separator. Yeah, up to C10 plus. And then this is the recombination information that we need in the laboratory to recombine the oil bottle from the separator or separator liquid and separator gas. And we correct GOR to laboratory conditions. And we have more accurate values of gas gravity and the compressibility factor for the gas. So it's recombined according to a gas oil ratio of 1940. And this is the recombined fluid and combined composition, the SAT composition of the reservoir fluid by recombination. And the recombination is a mixing correct ratio between liquid and separator gas into a PVT cell, or where we store the recombined fluid. Detailed composition of reservoir fluid, yeah, up to C10. And an extended one up to C20. And that is based on that the liquid phase is from the separator liquid has gone through a distillation process, vacuum distillation. And then we have the recombined fluid in the PVT cell, and then we can start doing to measure the physical properties of that liquid, how it behaves when we change. Typically what is looking at in the PVT lab, we have given reservoir pressure, temperature, because that is not changing during the production time. So we keep the reservoir pressure constant, and then we change pressures. So the first analysis that are done is a constant mass expansion. We have already, so we go down, start at the reservoir, above reservoir pressure, and then be in a one-phase region of the fluid, and then we stepwise reduce the pressure, and we can measure, calculate the SAT factor, and we can measure the relative volume differences of the fluid. All volumes refer to the bubble, to the dew point, which was measured to be 250 bars. And then we reduce the pressure into the two-phase region, and we start to precipitate liquid from the gas phase. So gradually we decrease liquid precipitation. So we start in at first pressure stage, hardly any liquid, and we have up to 7 volume% liquid precipitation as we reduce the pressure. So we come up to a maximum liquid precipitation, and then we continue further reduce the pressure, in this case 106 bar, and further reduction, then we start to reduce the liquid volume. And that's partly due to that the liquid phase is going into the evaporating components in the liquid phase is evaporating back into the gas phase. So we are going through the, yeah, it was not a good description of it. What we see is that the maximum liquid precipitation is generally so low that it's held back by the reservoir. It is less lower than the residual oil saturation for the reservoir. So, and that means that the main component that will be produced is the gas phase. So we hardly produce any of the liquid phase. And that's what we are doing in the next physical analysis, a constant volume depletion. And that's the typical way a reservoir, a gas condensate reservoir is produced. We don't normally do pressure maintenance during production of gas reservoirs. There's no water injection into the gas to maintain pressure. And when we are doing a pressure reduction below dew point, we see also here in a constant volume depletion, what we are doing, we reduce the pressure, and then the fluid in the PVT cell expand, and then we produce the gas back to the volume we had at dew point, VD, the volume at dew point. So we keep the volume constant. And that's typically what will happen when you produce your reservoir, if you don't have an active aquifer. So the reservoir volume is constant, and liquid will precipitate, and the gas is produced. So going stepwise down, and then the gas, we produce the gas back to the volume of at the dew point, and we can take samples of the gas and analyze it for the composition, and we can get the sat factor for the produced gas. So we know the properties of the gas that are expected to be produced from the reservoir as the pressure of the reservoir declines. And if we are going to design the process facilities, we need to be able to handle that type of production that we expect. So it's a gradual increase in the liquid volume. So if we compare liquid from constant mass expansion, that was maximum 7.18, and the constant volume depletion, we have a maximum of close to 6. Below 6, 5.83 at 130 bar. We have can calculate equilibrium gas, and we can calculate two-phase gas at the individual pressure stage. And we have the viscosity of the well stream. So if you want to evaluate the production as we're going from the dew point and further down in pressure, we can look at the plot the P over sat at the individual pressure stages, and then we can estimate how much of the fluid that will be produced. It will be more or less a linear line in the plot. So we, based on the pressure and the sat factor, two-phase sat factor, we can estimate what happened. So it will be in a way so we can give an estimate of the mole percent produced from the reservoir as the pressure declines. Okay, on page 16 in the PVT report, we have the composition of the well stream or the gas produced at the individual stages. So if you compare, if you look at methane, we see that it starts on 73.18 mole% methane in the production, and then it gradually increases to a maximum, and then it starts to decline again. So we're getting a more rich gas as we're closing down to the abandon pressure for the reservoir. So it's getting more methane into fluid, and then it declines again. If you look at the heavier components, we can look at the normal butane. It has the first gas that is produced at the dew point is 2 or above dew point should be 2.04 in molar %, and then it declines generally, and then at the end, when the pressure is going further down, we see that the heavier components increases in concentration. And as we said, so this is in a way the production and composition of the production during the lifetime of the reservoir, expected production. And this is the constant volume depletion. Okay, so the residual liquid, molecular liquid, so that's the residual liquid in the PVT cell at 51.1 bar. So then we see this is the liquid that are left in the PVT cell when we have reached 51.1 bar, that is the abandon pressure for the system, where we are not able to produce it anymore if we are not introducing artificial lift. So then we have a low concentration of methane and higher concentration of the heavy components. So that's what's left behind in the reservoir. The composition of the liquid, lost liquid in a way. What we have done there in the page 18 is the appendix, and in the appendix, the recombined fluid that we have been working on in the laboratory has to control the composition of that. We have done a single flash of that fluid down to standard conditions, and then we get the evolved stabilized oil from the single flash, and we get the evolved gas composition of from the recombined oil reservoir fluid. And then we mathematically can recombine it, so we know the composition of the reservoir fluid that we have. And the composition seems to be more or less in line with what we. So this is the real composition of the fluid that we had in the PVT cell, and I think the first recombination gave almost the same composition. Go back to page. Yeah, 73.18 was the composition based on the mathematical recombination with the GOR of 1940. So 73.18, that's the value of the mathematical recombined one. This is in a way the recombined one based on the real flash of the real recombined fluid. And the gas oil ratio for this gas condensate is in a flash process is 5,623. That's the GOR of the reservoir fluid at the initial conditions. And if you remember, there was a rule of thumb that the gas condensates typically have GORs from 3,000 up to 30,000. Typically. So it's in a way a quite, it's not a typical, what you should say, it's not a lean gas condensate. It's more a rich gas condensate. It's fluid. A richer. Okay. That was in a way the PVT report of gas condensates. I think we take 15 minutes, 10 minutes break, and then we continue 5 to 3, and then we'll go through the PVT report with the oil with dissolved gas, and that's the plan. Further, yeah,
Professor,
please.
if I may ask. So I was wondering, when you're working in a company and you're getting a PVT report,
Yeah.
it will be like this, right? This is from a well,
Yeah.
or from a field.
Yeah, that's correct. So this is from one single well, one zone in the reservoir, and there is most likely done several PVT samplings, and then you have to start to compare, and then you look at the individual composition, and then you do a proper review of it, and come up with what is the most likely composition. So one PVT report will not be a copy of the next one. There will always be variations in it. So you have to evaluate what is the most likely composition of the reservoir. And then definitely you can use PVT reports also to evaluate if the reservoir actually are two independent reservoir zones. Because you can see that there may be a significant difference in the composition from one part of the reservoir to another, and that there most likely are not a communication. There are areas of the reservoir that are no communication in between. And it's important information if you are going to where you are going to place production wells and things like that. So you are able to drain all segments of your reservoir. So it's important information that is a part of the PVT reports regarding an evaluation. And if you see that there are probably different segments of the reservoir with no communication, you may have to do more advanced analysis and looking for tracers, components that can confirm that there are low or no communication in between the reservoir zones.
Okay.
It's important information that is also as a secondary information that are in PVT reports.
Okay, thank you.
No problem.
First time you will ask for some information because you see already now.
So you want to be
You
could do that during the start learning.
Yes, of course. What do you think about Wednesday around 1?
I asked. Just two or more.
Practical maybe they are yeah, because then we have some original management to feel.
Okay, but let's also consider that we will have to give him serious request and all of those good words. The next time to deliver will be something that we always have to do the delivery before Wednesday, by Wednesday. So what do you think will be the best?
Before Wednesday, we should do this one.
How did you?
So it's better to choose something like that.
Yeah, we can choose. At least utilizing one.
But this is not important.
Let me see.
Waiting.
No.
Not yet.
Is there a deadline to make it?
No. Yes, I think.
It's 24 hours before the lab.
When is the lab?
You decide.
Yes. So if you go to modules, you can see.
I saw
You submitted your.
Like you write first time a task, I think your name, your phone number, your email.
And you could say,
Yeah, you could say.
then it gives you this. You choose.
And you choose the green is available.
Green is the logo.
Oh, so for example, when you choose a day, it's only you and the group member that you're with that can go to the lab.
Yes.
Nobody else.
No. As you choose.
And once you go to the lab, you need to do the exercise.
What?
Once you go to the lab, you need to do the exercise. It's mandatory.
Yes.
10 to 12.
Let's choose the day.
From 2 to 4.
No, this one.
10 to 12. Central under no register. You should do the same. I won't maybe send it or something.
I use my laptop.
No, but I will search for like when you are.
You can do it now.
Found. About exercise.
Here. Yeah, I think.
You found?
No. If I can find it myself. Oh. Yes. Just click not to save it.
It's not.
My phone. Just first you click login and then save. Oh, I found it here.
So,
Have you done the certification to use the lab?
Yes.
I think we did that earlier on when we were registering.
Yeah,
you should do the
station.
even before doing this.
Yes.
That's why it didn't.
That was so weird for me.
Doesn't take much time, right?
Well, I think you can straight go to the test, don't you?
Yeah, make logical answers.
Yes.
Is it you? What? Yes.
Not check this right there. We can.
Now it's
How many long? What am I
The one is with us.
Right, they didn't allow you to sign in.
Have you
Yeah, I mean, I signed up, but there was. It doesn't allow you because you. I should check the issues. I can see it.
George with.
Try.
What about this? There is one more girl that she just gave me one of
System noe som där man kan bara utge
in this WhatsApp group. You can text her.
Is she still there?
I will check group info. Participants.
I need to add all of you.
UIS Mario.
You should.
Jag kanske bara
He has.
Yeah, just.
jag har så
Spanish, so maybe I just have to class. 6, 5.
Hon var flaxig och så.
Can see.
Det där är ju bara liksom för början på att jag läser bara ställa alltså vanlig
Miguel.
No. He choose. I don't know what. I did it.
jag menar inte säga så man finner ut på något men kanske liksom går ju det är ju
Men man kan ju också.
ja ja
Is this girl only some?
I think he's not in PhD. She's not in PhD. She doesn't have this course.
To maybe she's even not repeating.
Okay, shall we continue? To get can finish this.
Professor, is it okay if I sit here and use the power?
It's okay.
Thank you.
sorry my computer is
Okay, we will look into, as I said, oil with dissolved gas, or this is a typical what we call a black oil. Black oil is just oil with low GOR. No big deal in between. So the amount of gas that are dissolved into the oil is relatively limited. So the GOR is low. PVT analysis is, so the PVT report here, we have a PVT analysis of the fluid. We are going to a constant mass expansion and a differential gas liberation, and there's also a separator test that we will look into. So a little bit different type of analysis that's typically done on oil with good dissolved gas compared to gas condensate. Just some definition, the BO factor, how it is the volume factor relative reservoir volume relative to the volume at standard conditions. So volume of standard conditions. So we take the volume or measured at for example bubble point, and refer to the volume at standard condition of the liquid. And that tells us how much the fluid expands. Okay, so there is a difference if you're doing a BO factor if you're going differential. So we are going stepwise down in pressure or maybe changes in temperature. So that's a differential process compared to if you're doing a flash. A flash process is that we take the one-phase reservoir fluid and flash it down to standard conditions. And then, so the DD is a differential process, and then typically we are using the residual as the volume, not the volume of stock tank oil, but the residual oil that is going stepwise at standard conditions. I'll come a little bit back to that. And then RS is the amount of dissolved gas in the fluid as we go in through the two-phase region. So it's a GOR. And then there's a PG differential, okay? Sorry. Reservoirs, so when we are doing input parameters in reservoir simulators, we need these parameters that are affect our system. But typically today, as I said, most oil reservoirs are produced above bubble point. That's the modern way to do it. But you shouldn't go far away. And if a lot of land-based small oil fields, they will never be. There is a large cost by implementing injection systems and handling produced water and things like that. So generally, it's difficult to implement in small reservoir a complete good reservoir management. But larger reservoirs is definitely pressure maintained during production. And typically what you see when we go from initial pressure, we go down to the bubble point pressure, we have a constant GOR. And then when we go into the two-phase region, we see that there is an increase in the gas-oil ratio as we lower the pressure. And that's why we try to maintain the pressure above bubble point. And we need information for when we are going to calculate the fluid properties as we are doing in PVT simulators. And so the PVT data is, or the results from the PVT analysis done in the laboratory is, we need that to tune the simulators so we get the correct behavior of the fluid. The simulator by itself, just based on composition analysis and is not good enough. There is too large variation from the simulated property to the reservoir property, the real property, the fluid. So it needs to be tuned. Okay, we'll come probably a little bit, touch a little bit into it. So PVT, black oil system. So we have an undersaturated oil reservoir, and most sandstone reservoirs in the North Sea is undersaturated reservoirs. So there has been a subsidence of the reservoirs over the time, geological time. So the reservoir was filled 30 million years up to recent, and with the subsidence, the pressure has increased. So the ability for gas to dissolve into the liquid phase has increased. So that's probably a main reason for undersaturated reservoirs. So we are increasing the pressure, and there is an extra hold capacity for gas. Okay, sampling data given here. Yeah, this is the content of the PVT report. There is an introduction, fluid samples. It's a fluid samples that are sent to the laboratory. It's not a bottom hole sample, but it's samples from a separated test. And that's typically what you get into, in most cases, into laboratories. Bottom hole samples are more rare and more significantly more expensive. And there may be just a few samples that test that are volumes enough for just a few tests to be done from such fluids. Okay. Sampling data, we have a interval tested is at 1833.8 meter. It's a Brent. Reservoir fluid is oil. Brent formation, production zone, geological, typical geological sequence in the North Sea. Reservoir pressure is 308 bars, and temperature is almost 72 degrees. And what we are dealing with in the laboratory is two different, one oil bottle and one gas bottle. There may have been a selection in front of that. So they may have received several bottles, but this is the two bottles that they have worked further with.
Is the selection based on the nitrogen composition?
If this?
The selection is based on the nitrogen composition.
No.
Because it was in the.
Yeah, we will come back to that. I will comment the composition, but of fluids. But no, the nitrogen is not the important part in this test. But what we see here from the separator test is that there is a gas rate. So we are producing 53,000 standard cubic meter per gas per day over the test separator, and we have a liquid production of 653 cubic meter per day. So it's quite a large volumes you need to handle during a separator test. Gas oil ratio of 80.4. And the measured gas gravity and sat factor at the rig based on the limited information is given here. Gas gravity of 0.62 and sat factor of 0.95. And then the separated liquid bottle is going through a bubble point determination. And we start at a high pressure and reduce the pressure and go into the two-phase region. And we start to boil out gas, and we are able to detect it when we're plotting volumes against pressure. So you see a change in the compressibility of the fluid. And that's used to detect or to verify the bubble point. And the bubble point of the separated liquid is measured to 26.3 bar, and the separator pressure was 26.2 bars. Confirms that it's most likely a equilibrated fluid that is taken at the test separator. It don't contain too much gas and don't contain too little gas. Okay, so that's what that page 6, composition of separated liquid from a single flash. Get a gas, liberated gas, and we get the stock tank oil, and we can analyze the composition. That's what you're going to do in exercise number 2 in the laboratory exercises. So do a GC analysis of a stock tank oil. So then we see there's so little of nitrogen, hardly any nitrogen in the evolved gas. Quite a lot, almost 3% carbon dioxide in the gas. So most reservoirs contain CO2, both gas reservoirs and oil reservoirs with dissolved gas. You can look up in the compendium, and there is a description where the CO2 could come from. It could have both an inorganic or organic origin. Okay, we have a composition here. We can recombine it based on the GOR. And we get a composition of the separated liquid in mole percent, normalized to 100%. So if I want to have the GOR differential, I can take the GOR from the separator, from the flash, and this is the GOR from the flash, and this is the GOR from the separator. And then I end up with the GOR for the reservoir fluid of 93.6. If it's going through a two-stage differential process from separator through from reservoir through to a separator and to a flash. Detailed composition. What we see from the detailed composition up to C10 is that I can calculate the different components or both the molecule weight and the density of the fluids. And we see that for the decane plus, I have a molecule weight close to 295, and that represents the carbon number of 21 to 22. I have a density of the C10 plus of 0.9, and that represents the carbon number of 29. So seems to be something not completely, not a complete material balance here. And that's in a way, within these limitations here, we can toggle a little bit with our fluid when we are modeling the fluid. So we can change the composition of the density of the plus fraction and the molecule of the plus fraction and see if it fits better. Okay, then this was on page 8. We have a detailed composition of separated gas. The gas bottle that was delivered to the laboratory. We have flashed it, get the stabilized gas, analyzed it, and we get the composition of that. So we see that hardly C5, we have a gas component, a significant amount of the individual components up to C5, and hardly anything above C5. Very small contribution of the components above C5. As expected. So the gas molecule weight is can be measured or calculated, and the gas gravity could also be measured. Specific gravity of gas in the lab. Okay, recombination of the separator. So we have the GOR that was 80.4 at the separator. We have the flash on the separator. So, okay. So yeah, so this is the fluid that we are recombining. We have the gas bottle at separator, and we have the liquid at separator, and we recombined it according to a relative ratio between oil and gas of 80.4. And then we get the reservoir fluid sample. And that's what we are doing in the laboratory. We make a recombined sample, constant mass expansion. The first test that we are doing, we are reducing the pressure, gradually reducing the pressure. Start at a high pressure. We have the initial pressure of reservoir of 308.1 bar, and then continue reducing the pressure until we go into the two-phase region. And the PB is 239. The bubble point pressure of the fluid is 239 bar. So if you make a phase envelope of that fluid, we are to the reservoir temperature is to the left of the critical temperature. We're going through the bubble point line of the two-phase envelope. And typically when we produce a reservoir, the reservoir temperature is more or less maintained during the production. Definitely, if you are injecting large quantity of water, there may be a small change in reservoir pressure over time. But if you look at the mass, the mass of rock is significant more than the mass of the fluid that are present in the pore space. So you should have large quantities of water to cool down a big reservoir. so okay, I factor is in a way used to evaluate if the fluid sample is a correct sample, it's not polluted, and if it should come out as a straight line. And so it's a quality check, but it's not an absolute quality check. Let's say it like that. So it's a good indication, but it's not a perfect. And that's what you're doing. Do quality checks, different type of quality checks, and everyone confirms that it seems to be a good quality. It's better than have no references to quality. Compressibility is a part of what we are doing, important part. It's linked to the BO factor. And then we do a single flash of the recombined fluid. So single flash of the recombined fluid, and we get a stabilized oil, and we get evolved gas, and we can calculate it back to a composition. And what we see is that 34% or almost 35% of the molar percent of fluid is in the C10 plus fraction. So when we are going to describe the fluid, it's based on a 1/3 of the fluid is based on a plus fraction that we don't know exactly the properties of and how it behaves. So there is a room, and that's giving the problem for the PVT simulator, and that the need of tuning simulators to the system. Okay, so GOR from the flash is 97.8. So it was above the 93 point something that we had, 93.7 from the separator and GOR and flash. Confirming what we said, that the more separator stages you have, you will reduce the GOR, and you will end up with more stabilized oil relative to the amount of gas. And this is a detailed composition of reservoir fluid up to C10 plus, and I think maybe, yeah, that's correct. And then the next step, analysis that done in the lab, is differential gas liberation, and that's what will happen if we start to produce the reservoir below the bubble point. So we start at the bubble point and reduce stepwise reduction in pressure and equilibrate the fluid, and we will have, instead of, as we had for the gas condensate, we had liquid that precipitated. No, it's gas that are getting evolved from in the two-phase region. So we end up with a gas phase and an oil phase. And then we get stepwise GOR on solution gas in the fluid, and we get the BO factors, and we get a BG factor of the gas phase. And we have density, reservoir oil density as we go into the two-phase region. Compressibility factor of the gas, and viscosity of the gas. So if you look at the viscosity of the gas, we definitely don't have a gas above bubble point, and we see that the viscosity of gas is decreasing as the pressure declines. If you plot these values. And gas in solution is calculated based on the volume of gas we have at standard condition divided by volume of oil residual oil. So here is the residual oil. The relative volume. They all refer to volume at 1 bar, 1 atmosphere and standard temperature. This is from the, so what we did a gas liberation test. We reduced the pressure stages, and then we produce all the gas are on top of in the PVT cell. We take out all the gas and we analyze that gas from the gas liberation test. That gives us access to gas, so we can measure viscosity or calculate viscosity and set factor for the fluid. And this is the composition of the produced gas in the two-phase region. And this is the composition of the residual oil after all the differential gas liberation. And now the decaying plus fraction molar composition of that has increased from 34% to, as for the reservoir fluid, now we are at 71% in the plus fraction. And there also an increase in the molecule weight of the residual oil. Viscosity of the reservoir fluid, decrease in viscosity, then we reduce the pressure. That's what we see. We start at a high pressure, reduce the pressure, and the viscosity of the liquid phase is reduced as we reduce the pressure. And we have a minimum viscosity at the bubble point. And then the two-phase liquid, viscosity of the two-phase liquid is increasing as we boil out more of the gas. So that's the general trend of viscosity of oil. Small change and a reduction in the viscosity of the oil as we go from initial pressure to the bubble point pressure, and then we have an increase in the viscosity in two-phase region. And then there was the multi-state separator test that is done. So what we are doing, we are going stepwise down in pressure and temperature at the same time. So 1, 2, 3, 4 stages. And if we sum up the GOR on the individual stages, we end up with 93.4 in GOR, a little bit less than a GOR from separator plus flash, and significantly lower than the GOR from the single flash. And then we also have the composition of gas at the individual pressure stages, separator stages. So then we know also the composition of the gas we are producing. And this is the composition of the stock tank oil that is produced from the through the separator stages. Yeah, and at the end there is the mathematical recombination of separator samples, confirming the composition that we have. So it's in line with the previous, the flashed sample. And a more detailed composition of it. So that was in a way the typical PVT report from gas condensate oil with dissolved gas. The information you can pick up from that. Okay, that was the plan for today. Next chapter in the compendium will be published tomorrow, I hope. I'm still working on it, so everything is fresh. Yeah. Then we'll continue on Monday with going through calculations that are based on gas systems. And then we will have on Thursday, we will have the last hour in lecture, we will introduce the exercises. And the student assistant will be present and give you a little bit of his plan for supporting you during problem solving. Okay, thank you. See you on Monday. Any questions from the Zoom people?
No, I think everything was pretty clear. We could hear you pretty well throughout the whole thing. So yeah,
that's good.
Good.
Can't be better when everything's or the technology is working.
Yeah, exactly. It's not a given, so it's good.
Okay.
But yeah, thank you.
See you all on Monday. Bye.